Alright guys, so this video is here to tell you about the chain rule. So the chain rule is probably the most powerful technique you learn for taking a derivative. It's incredibly useful, and it's something we're going to see throughout the year. So here's what the chain rule lets us do. Like, we can differentiate something that looks like this. So if I give you, for example, y equals sine of x, or y equals the square root of x, you guys hopefully can take the derivatives of those. But what about something like y equals the sine of x cubed? Or what about y equals the square root of 2x plus 3? Like, where we have something kind of inside the parentheses there that's not just an x. And the chain rule is going to allow us to answer those issues. Again, it's extremely powerful. So let me give you the equation for the chain rule, talk about kind of where it comes from and how it works, and then we'll go over some examples. So if you have a composition of functions, so just as a reminder, if you have f of g of x, so say your f of x is equal to, I don't know, like cosine of x, and then your g of x is, say, like, I don't know, 3x plus 7. So if you take f of g of x, it's basically saying just replace the x with g of x. So instead of taking f of x, you're replacing all the x's with the g of x. So instead of doing this, we're going to have a g of x there in the circle. So in this case, f of g of x is saying, like, okay, we're not taking the cosine of x, we're taking the cosine of g of x, and then we could just take this function right here and plug it in for the g of x. So you could write this f of g of x as the cosine of 3x plus 7. Okay, so that's what f of g of x is and means. So let's go back to what the chain rule is now. The chain rule says that if you have to take the derivative of a composition of functions like this, so if you have to take the derivative of y equals f of g of x, that derivative is y prime equals f prime of g of x times g prime of x. So let's break this down first off. So what we've done here, this f prime of g of x, so that's you taking the derivative of the outer function, and then you leave the inner alone, and then you multiply by the derivative of the inner function right there. So that just gets multiplied on the end. So you leave the outer function alone, you leave the inner function alone when you take the derivative of the outer, and then you multiply here by the derivative of the inner. Okay, so let's go ahead and look at a few examples of what this might look like. So we're just going to differentiate several things. So say we have the sine of x cubed. Okay, so in this case, your outer function is the sine, that's like your f. Your inner function is the x cubed, that's the g. So if you would try and guess this on your own, might be a good idea. But when you take the derivative, okay, so we start by taking the derivative of the outer. So the derivative of sine of something is cosine of something. So it's cosine of that same function. So the inner function stays the same. And then you multiply by the derivative of the inside, the chain rule, so 3x squared. And the only thing you could do here is just clean it up, move the 3x squared to the front, so 3x squared times cosine of x cubed. Okay, so that's one example. Another example you might see, suppose we have to differentiate, say, y equals 3x plus 1 to the 20th power. Now again, if we had something that was like y equals x to the 20th, we'd start by just saying, like, let's bring the 20 down. So it's like 20x to the 19. And I'm going to do the same thing here. So kind of whatever's inside parentheses, that's your inner function. So thinking about, like, what would be in parentheses if you wrote it out properly, that's like your g, using the notation with the f of g. Okay, so here the 20 comes down, so it's like 20 times 3x plus 1 to the 19th power. And then by the chain rule, we multiply the derivative of the inside, which is 3. So we could write it as 60 times 3x plus 1 to the 19th power. Okay, so that's the idea. Again, you're multiplying, you're like taking a derivative like normal, leaving that inner function alone, and then multiplying by the derivative of the outside there. So we'll do a couple other examples. So suppose we have the function f of x equals 1 over 3x plus 2. Now, this is something you could easily do using the quotient rule. But you could also rewrite this as 3x plus 2 to the negative 1 power. So you could use the quotient rule, but you can also do the chain rule on something like this, and I find it easier. So we'll bring that power down in front. So we use our normal power rule, so it's like negative 1 times 3x plus 2 to the negative 2. And then because of the chain rule, we multiply the derivative of the inside, which is 3. So again, whatever's in parentheses, that 3x plus 2, That's the inner function. The outer thing we're doing is the exponent. You clean this up also, negative 3 times 3x plus 2 to the negative 2. And if you do the quotient rule, you'll get the same answer. Okay, so let's get a couple other of these basic examples. So say we have the natural log of 3x plus 7. Now again, I want to draw just a reminder to what happens if we just have ln of x. Well, you take the derivative, you just get 1 over x. So we're going to start with that same thing. The derivative of ln 3x plus 7 is 1 over 3x plus 7. And then by the chain rule, you multiply by the derivative of 3x plus 7, so times 3. If you want, you could write it as 3 over 3x plus 7. Okay, so that should work out fine. Just one more example with like a natural log here. So let's say we have natural log of 2x to the 5th minus e to the x plus 1. All right, so same thing. Don't get intimidated by all this stuff. When you take a derivative, you have 1 over 2x to the 5th minus e to the x plus 1. And then by the chain rule, we're going to multiply this whole fraction by the derivative of the inside. So whatever's in here, that's like our g, that's our inner function. So the derivative there is 10x to the 4th minus e to the x. If you want to clean this up into one fraction, you can. You don't need to, but you can write it as 10x to the 4 minus e to the x over 2x to the 5th minus e to the x plus 1. Okay, so that's the chain rule, guys. So the key here, really just take the derivative of the function, leaving the inside alone, and then remember to multiply by that derivative of the inside every time. I know it looks a little weird. This is something the more you practice, the more you're going to become familiar with. So hope it's helped, and I'll see you guys soon. Bring me some questions.